I'm Dusty Kokenberg. I'm the Director of Marketing here at Scale, so I'll be moderating. I'll pretty much be on mute the whole time. If anybody experiences issues or anything, feel free to reach out to me in the chat. Just some quick housekeeping. One thing, please use the Q&A functionality as opposed to the chat for your questions. We do have two panelists on that will be running the Q&A section, so it's a lot easier for them to keep order in there and know what we've answered and what we have not. When we get to the end for the Q&A, what we'll do is we'll pick some of the relevant questions that have come in, and we'll have Mikey talk to those. So we'll go ahead and get started with introductions. So the presenter today is going to be Mike Lyon. He is our Service Delivery Manager. And then two of the panelists that are on is David Paquette and Blake Rodier. David is representing the product marketing, product management team, and Blake Rodier is part of our support team. So with that, Mikey, I'll hand it over to you, and we're good to go.
Awesome. Thanks a lot, Dusty. Well, thanks everyone for joining us. I know this is the first week back from probably a busy and hopefully relaxing and disaster-free break. I'm still getting my head back into it's 2017 mode. Let's start off and hit the ground running with some new plans. So now that I've got my brain engaged this week, I'm going to talk about why we're here today. And really, I want to talk about disaster recovery, but specifically, if we look at what's built into HC3, to Scale Computing's infrastructure platform, what are your options for protecting your data? And at this point, at least within the past 3 or 4 years, I'm sure you've probably been on 2 or 3 DR webinars and been invited to dozens more. So I appreciate you coming on and joining us today, talking about not just specifically to HC3, but how do you do disaster recovery planning in general? If that's something you either haven't started on or need to reboot your existing plan, talk about how you can approach that better. And then how can my team with Scale Care Professional Services, how can we help you take that next step to get a DR plan put together, get one in place, get one that's testable, really to get you in a position where you can say with comfort and with confidence that if disaster strikes, I know what's going to be happening, and I'm ready for it. So just talking about our core values of Scale, and this isn't necessarily going to be all about Scale and HC3 today, but I want to make sure everyone's familiar with what we are. But our core values: simplicity, availability, scalability, and affordability. So obviously, we're going to be talking specifically about availability, but in reality, we wanted to make something that was simple, where you're managing your applications and your virtual machines that run your business, not the hardware or the software underneath. It's really managing your cluster, managing your applications, not the hardware, not the software, not the SAN, nothing else. As far as availability goes, and we have a tremendous amount of features built in that enable DR, that enable you to have resiliency in your applications and your virtual machines. But how can we also make sure that those are even more protected for whether it's human or natural disaster? And then scalability and affordability. When you're ready to grow, because no one has a perfect crystal ball or concrete roadmap for their infrastructure necessarily for the next year or 2 years. When it's time to grow and you need to grow, making sure that A, it's an affordable option, B, it's not going to be a complicated rip and replace where you have to see if there's going to be compatibility or if you're going to have to forklift everything just because you need to add a slice of resources. Being truly scalable means I can add on demand and non-disruptively. And okay, that's fantastic. That's what we're about. What does this really mean? What does that definition of disaster recovery mean, and what does that mean and what does HC3 do? So, as far as today's virtual infrastructure, whether you're in a physical or a blade center, really what you have is a set of physical hosts, whether it's blades, whether it's storage, and even though the components may have changed over the years, in reality, we haven't changed what we do underneath a whole lot. There's faster SANs, there's faster disks, there's faster hosts, but the way you're managing your environment with physical hosts, a shared storage component somewhere, whether that's an inexpensive SAN or a NAS or something more elaborate, And then you have another management layer to oversee that, vSphere, vCenter, SCVMM for Hyper-V. So there's that other component where you have to say, okay, I have to have another dedicated box to be my manager of managers. And all of those have their own support contracts, their own termination and end-of-life dates. And also you have to make sure that they're compatible with one another. That can be an exercise in utility and frustration in and of itself, as different vendors change their life cycles, and are they going to be friendly and maintaining compatibility so it's always going to be supported. Those are the questions you have that we've always had when we're building and designing hardware and infrastructure. And that's really where hyperconvergence came into play, and what virtualization with HC3 is really all about. Simplifying everything so you're just managing your VMs. You don't have to worry about anything else that's underneath the stack. Some of the specific features, we talked about the simplicity. We have a single management interface for everything. It's browser-based. Everyone has access to a browser, and everyone knows how to use the internet, so we don't have to go and relearn this new way of managing technology. Automated snapshots. Last year we've added a hybrid clusters with both SSD and spinning disk, built-in replication, and realistically to get to a point where you can log into that browser, connect in, and start uploading ISOs and creating VMs. That can be done in less than an hour. And same thing with when you're scaling and adding new nodes. That's done with no downtime. It's really a matter of configuring an IP address on each node and powering it on. There's not going to be configuring storage. You're not going to spend another couple of days setting up your physical host. It's all done with just 3 IP addresses. And it's really a turnkey experience. And then from a DR standpoint, if you need to have a hosted DR option, that's available as well. And we did design our product from the get-go to be a mid-market / SMB platform. We didn't design a product for enterprise and Fortune 100, and then neuter it of any features that make it worthwhile, easy to manage and functional in order to make it affordable. We took all the features that we knew we wanted to have and built it in from day one. So when you're buying a cluster, you're not going to have to buy, your hypervisor licensing on top of that, or worry about what's, how I can have to install it, installations included. It really is a turnkey experience of getting the cluster up and running. And then the process of moving your existing workloads over, whether that's physical or virtual, is also fairly easy and straightforward. I mentioned we do have the tiered storage nodes, hybrid nodes, so for both our 4 and 8 drive systems. We've updated our entry-level node with the newer hardware. We've built in snapshot scheduling, which I'll demo that in some detail a little bit later. Per VM, as well as cluster-wide statistics. You can now get a snapshot of your individual VM level stats, its throughput, IOPS, the CPU, as well as the entire cluster. And so that in a 7-minute window is what Scale and HC3 is about. So let's start breaking some things. So again, we don't need a rearview mirror here to look back and see what happened in 2016. There was hurricanes and floods and fires, and those are what we always think about when we're talking about disaster recovery. So let's define DR. And there is a by-the-book definition, I'm sure. Everybody has their own. I prefer mine, which is homegrown / plagiarized. But really, boiling it down, there's three steps. There's planning, preparing, and protecting. It's what am I going to protect, how am I going to protect, and let's start doing it. Now, obviously, this is really missing half of it because the other part of any DR plan is testing. But at a whole, disaster recovery is these 3 steps. And we've all done it in some way, shape, or form, whether it's backing up to an external USB or taking a snapshot before we run Windows updates. We've all done some way of making sure we have a safety net. Now, how elaborate or sophisticated or testable that is going to be up to you. But what would be the minimal requirements? And I'm using minimal in quotes as it, again, is my interpretation, but everyone else has their input on what you think you should be done. But first you have to have a place to put it, a site. This can be somewhere else on your campus network, within the same building, but preferably across town in a different LED, a different power grid, or different FEMA zone. But that's, going to be the hurdle number one is do you have a place to put your equipment? And is it going to be something your users physically access? Figuring out that site is going to be important. Then do you have a plan? Do you have something in place at all today to say, okay, when disaster strikes, these are the steps we're going to take. These are what we're going to do to recover our data, get our users back up and running, get their business applications up and running. How is that documented, and what does that strategy look like? Have you picked a platform, a vendor or product that you're going to use? Are you just going to do it, a DIY approach, or are you going to go with a agent-based software installation? And then do you have the budget and the finance for it? It's easy. I always find myself getting way down a path until I step back and look at, okay, do I have the funds to make all this work? And that's, number one and number four are probably going to be the most challenging. But, we, as technologists, we hate documentation. So it's hard to keep that plan fresh and living. It's like a documented DR plan should be, as well as it can be a challenge to getting management to invest or reinvest in DR. If they've put out some money, set up a site a few years ago, I think people who don't make technical decisions on a daily basis tend to forget that it's not a set it and forget it and a fixed cost, that there's going to be ongoing care and feeding and maintenance, and that DR should be a line item in the budget ongoing, not just, okay, it was 2014, we built the site, you're going to be good to go. So talking about built-in features that HC3 has to make DR come to reality. So yes, they're DR features, but really they are resiliency tools. They enhance availability. Empowering true disaster recovery with snapshots is an easier way to keep an instant recovery point. And it's automated around your retention policies, your schedules, and based on the needs of your business. Replication, if you have another scale cluster, whether it's somewhere down the hall or it's elsewhere in the world, as long as you can reach that via VPN tunnel, you can replicate your VMs instantly to another cluster. So those are full copies of VMs with snapshots that you can recover from. I'll demo that shortly. And then also for recovery, locally, maybe it's not a disaster, but it's you want to have a recovery point prior to testing on a patch, or you want to have a sandbox to test out a product update. And those are, DR and risk mitigation events that don't necessarily coincide with a fire or flood, but they could certainly lend themselves to data loss or to users disrupting your users and their access to data. So, and having things like clones and snapshots, even as recovery points for daily events, will really help us, as I would say, save us from ourselves. And we tend to be a little bit click first and apologize later. Those VM snapshots, they're practically instantaneous. You can keep thousands of them per VM, and they're very efficient as far as the space that's consumed. It's just going to be what has changed between the snapshot intervals. So they're all blocks unique to that VM and those VM disks. Taking them and scheduling them does not affect VM performance at all. So there's not going to be an ongoing performance degradation. You don't have to keep track of the hierarchy or worrying about if I delete them, what's going to happen. And you can keep thousands, like I said. And what do I do with those snapshots? Well, we're just going to take a snapshot and say, I want to clone and create a VM from that point in time and start it up. And if you have hundreds of snapshots and you want to clean and prune those up, again, you can manage those without any overhead of your I/O or worrying about if I delete a snapshot from 4 weeks ago, is that going to affect anything else that's happened? No one should ever be required to keep track of that level of pedigree of data. Keeping it easy if you want to make it as easy as possible. Taking those snapshots, you can also schedule them all the way down to by the minute if you've got the bandwidth and the change that supports it, all the way to monthly or yearly. And you can have multiple rules set up in a schedule. So if you've got some some levels of sophistication where you need to have, hourly, weekly, monthly, yearly. You can have a nested schedule like that all snapped onto one VM or multiple VMs. And it's going to work the same way for replication. So whether you're taking local snapshots, again, I have this set up, the schedule set up. I'm taking a snapshot every 5 minutes. In replication, I'm just going to use that same schedule and ship those snapshots across to the DR cluster. So your RPO and RTO, the schedules you design into your snapshots, are always going to be reflected immediately and instantaneously on the DR side. But even without a second cluster, like I said, it does give you a nice recovery point to go back and say, okay, this was before we got CryptoLocker, this is before we decided to update and trust Microsoft, things like that. The other component to having snapshots is thin cloning. So when we're going to recover, we're going to go back to that specific snapshot at that point in time, and we're going to make a clone of that VM. So that clone VM is a descendant, if you will, of the original VM. So they are not linked. The original VM can be deleted, load away. Again, you don't have to keep track of that. But as their descendants, the only unique blocks that are consumed are the additional blocks that are unique to that VM. So when I power that VM on, even though it's a clone, all that's really going to change is I turn that VM on, I run that, download that patch, et cetera. The underlying, maybe 15 gigs of the core operating system, those are going to be remain shared. So it is a very space efficient clone, and it's easy for you to make templates or gold images. So if you want to have your template set aside, ready to go, again, it's common OS blocks. You're only sharing those, consuming those once, and they basically become unduplicated. And then also, again, for test dev, if you want to have a sandbox or a safety environment, it's a really nice option to say I have an isolated lab network that you can create on demand simply by cloning a VM. Even without snapshots, I can take a locally, live running snap of that VM. So let's get back and bring up a cluster interface so we can see it. Hopefully this is big enough for everyone to see here.
Yeah, you should be good.
Okay, cool. So this is your management interface for the cluster. Again, to get to this point, really, I've powered on each one of these nodes, I racked them, and I gave each node an IP address, and then there's a backplane network IP address that gets provisioned, and that's it. I didn't have to configure anything else. So once the cluster has been initialized, I can literally just go to a web browser, punch in the address of any one of the nodes, and I can log in and have access to it. So in this case, I've already got some VMs configured, as you can see. I have not set up replication. All I've done here is set up a snapshot schedule. So I've got this schedule here called every 15 plus daily. And if we wanted to look at what that schedule looks like, see there's 4 rules in here. How many VMs are using this. So every 15 minutes, take a snapshot and keep for 5 hours. So 4 per hour, I'm going to keep 20 snapshots of 15-minute intervals. Keep it daily for 1 day. Keep a monthly for 2 weeks. Biannually for half a year. This is just a sample one that I created. You can get as sophisticated and as granular and as detailed as you want to be. The only thing that's going to really restrict you and limit you is if you are doing replication, if you've got a schedule that's going every 5 or 6 minutes, just know that if you're doing that many replications of hundreds of VMs, you may want to stagger those a little bit. But the other thing is capacity. So it is pretty easy to say, oh, I want to keep all these snapshots. It's great. And even though they're tracked as unique blocks to those clones, and snapshots, it's pretty easy to say, oh, I can keep a year's worth of thousands of recovery points. You know, you certainly want to keep an eye on your space consumption as you're considering that. But if you wanted to see, I can look and see here's the size of these snapshots, you know, from within the 15-minute intervals, what had changed in between there. So that's fantastic. I want to go back, let's see, a little bit before lunchtime. I pulled down an update. So I want to restore a VM from that point in time. I'm just going to pick that particular point in time, that particular snapshot, and I can power my VM on, and away I go. So at that point, I have essentially engaged DR locally. I've got a copy of this VM that I can now power on. If something happened to this one or it was corrupt, I can blow it away and get rid of it. In this case, you know, I would have 2 domain controllers running on the network, so I'd probably want to disconnect some of these NICs. But that's in those 5 clicks is how difficult it was to restore and get that DC back online. Now, if I want to take that and move it to another cluster, yeah, all extremely easy to do and to point that all through a web browser. So I could pick my target cluster, or if I don't have that target cluster yet, if I want to add it in there, credentials and the remote IP address. That's all you need to do. That's going to be your remote cluster. So once I've got that, I've already got one set up, so I'll just pick this cluster. And we'll start replicating. And within a minute here, we'll see that basically a container VM created here, the target cluster. And we're going to start taking a snapshot and then sending the additional snapshots across the wire to this VM. And in a case where I've been replicating for a while, you know, the restore point, again, if I'm in DR mode, I want to go back to a point in time, I just say, okay, this would be my target cluster example. Again, within a few seconds, you can have that VM powering on and up and running. So there's a little bit of a gap, as you can probably see, from how do I get the data from here to there, and what are the requirements to get the 2 clusters connected and talking to one another. Well, they're fairly simple as far as the requirements go. The first thing you need to have is, again, we're talking about replication, move it somewhere else. It can be another cluster or a scale single node. So if you have a single node, you can deploy that as a replication target, which is a pretty nice approach if you just have a handful of VMs that you really want to protect, and you don't have to move your entire environment or replicate it. So whether you're sending these to a single node or a cluster somewhere in a data center, as long as your 2 clusters can talk to one another, you can move those snapshots. So you can stand up that cluster or single node at a remote site. And again, using the same snapshot schedules, we're going to continually replicate the snapshots, only sending over the change blocks. So with fast cloning, your recovery points and recovery times can be very low. Most importantly, you know, we fail back too. So if the original VM is intact and the original VM exists, the cluster exists, as long as there wasn't a true disaster where things were burned or flooded, if it was a fiber cut or something more human and we can get access to that cluster, it's very easy to simply fail that back. So we would just reverse the replication job and then send the VM back. So if you were running for DR or running in DR for a week, and that was a 50 gig VM, let's say, you're not going to have to go and send the entire 50 gigs back. As long as that original cluster was intact, you're just going to have to send what had changed, on that snapshot, what's been going on for a week. So maybe it's 2 or 3 gigs worth of time to fail back instead of all 40 or 50. So it's a nice, easy way to say, okay, failing over is wonderful. Half the reason people don't do DR tests is because failing over is is easy, but failing back is a nightmare. And that's really where we've made it exceptionally simple. So what do you need for replication? What does that checklist look like? You need somewhere to put it. You have to be able to get to it. And there are no requirements for bandwidth. But 10 megabit or greater is really what you're going to want to have, simply because if you do have an aggressive snapshot schedule and you need to keep a large history of snapshots, or if you have a lot of change inside the VM, so maybe within an hour you have 5 or 6 gigs of data and you need to shove that across a 10 megabit link, that may not be enough. So bandwidth is really going to be, as with anything, as much as you can possibly afford would be best. But you don't necessarily need a lot, especially with single nodes. We can do staging fairly easy just by deploying those locally. Okay, so again, let's look at the minimum requirements we have for DR. You've got a place, you've got a strategy, a vendor, you've got some approval, you've got capital. You have all the green lights you need, but you don't necessarily know where to go. And maybe you've got all those things, or you just want to start over. A new year is a great time to hit Control-Delete and kick off a new DR plan, especially if you're facing an audit or you really want to have some faith and confidence in having a plan that's tested and that works. That's where we can come in, and that's what our disaster recovery planning service really is all about, where it comes into play. And so, as you've seen from the demo I just gave, DR with Scale is exceptionally easy. But it's not just having the technology underneath; it's having the plan, and that can be the hard part. Do you have the configuration? Do you have a test plan? Do you have a runbook put together for executing and orchestrating your plan? And do you know how to walk through a failover and failback? If these are things that you really aren't sure and you need the knowledge transfer or someone to help you complete that entire plan, not because it's hard or because you can't do it, but most of the time it comes down to manpower. We don't have time necessarily in the SMB and mid-market to sit down and lock ourselves away for a week and draft up a DR plan. Those aren't things that we necessarily are doing on a daily basis. And even if we should, it's just, it never becomes the priority it should be, but that's life, and that's why we always have DR webinars and go through exercises like that. So that entire DR plan, that Scale Care DR runbook that I'm talking about, that's a nice piece of collateral that comes from our DR as a service offering, because we include that as well if you're a DR as a service customer. But it seemed like there was a gap for customers who didn't need DR as a service or didn't want that. They have either plans to or have deployed a second cluster, but they don't really know where to go. Because it's more than just a plan. It's a snapshot of your environment. It helps to map application dependencies, workload optimization, and remote access documentation. Are you running things the way they should be? Have you configured it and optimized your VMs for DR? Capacity management and being able to plan for, is your remote target cluster sufficient or is it too much? And these are things that are a part of it that we can help you get started with. And it's more than really just that plan. It is a strategy, and it's something that's testable, and you can prove to yourself and prove to management, prove to whomever that, okay, I have a DR plan that is working. So from what you see here, yes, these are sample pages from our DR plan, but it's comprehensive in everything that's covered. Again, this is descended from our DR as a service offering and that proven technology. And honestly, the runbook and having a DR plan has really been probably the thing people thank us for the most, is having that they can print out, they can have in their hand, and that they know to a certainty because they've tested it before that they have a DR plan that works. And specific to you, it's customized to your environment. It's using our collateral. And I can't emphasize enough how important it is to have a testing plan accompany your DR strategy, as well as having a failback plan. And how do you actually validate that it works? It's usually important to bring other stakeholders from the company or organization in to make sure that, from our perspective, we see the technology is working fine, it's up and running, whereas as a user or administrator of an application, they may not be seeing or experiencing the same things you are. So the other part of a DR plan that can be challenging is how do you actually set up and access DR? I've protected the data. I know it's elsewhere in another cluster. That's great. But now my users who are used to coming into the office every day and logging onto their workstation, you need to figure out what to do. And this is where we help you figure out, okay, what is your initial strategy going to be? Are your users today used to using VPN? Are they mobile and familiar with that, or that require some training or additional licenses? Or do you want to set up a hot site and have, your users physically relocate to temporary office space, where you could have a single node shipped or deployed? Those are the strategies and how your users actually access the data and get to the applications when they're at DR. That becomes roadblock number 2 after having a plan and trying to put a test together is, okay, what do I do to make this work? And when you're faced with some of those questions and not sure where to go, and that's probably overlooked, I'll say at least as often, if not more often, than actually having a test. So we provide guidance around that and examples from existing customers. And again, this is something that we try to get as simple as possible. And as a part of the discovery process, learning what are you using in your environment today, that makes sense that we can recycle as remote access technology. Like if you already have terminal services CALs, that would make an easy way to say, okay, let's have everyone just connect up via RDS, in DR. Just examples of how we can help you make sure that when you're in DR and when you're going through that test, that the users are actually able to access the data. Because it's not going to do any good if it's up and running and no one can get to it. So HC3 is fantastic for an infrastructure platform, but why is it fantastic for disaster recovery? Well, outside of everything we just looked at, one, there's nothing to install or maintain. There's nothing that gets installed on the cluster, in the guest VMs, anywhere. You don't have to touch or manipulate the guest OS. It's built in and it's free. There's no cost to it. The only cost you're going to have is your bandwidth, the rental on the other site, and the cost of the node. So as long as you're using it, you're up to date on your support contract with us, and there's not going to be a cost to it. Easy failover and failback. It's so important to have an exit strategy for your DR. It's common, and so the folks from Vision Solutions told us this story. They would often run into customers who had failed over and didn't tell them, and they were actually running in DR for months on end because they didn't want to fail back. It was too daunting an experience for them. And there's multiple avenues for you to get at your data. Again, those are things that we can help you set up and strategize on, or if you want to have multiple paths yourself, you can have a hot site with a VPN backup, or however you want to be able to say this is how we're going to access our data. And having the flexibility with multiple ways to approach it is really another, I guess, cherry on the sundae there. And then with the ability to go back and say, I want to get that snapshot, you don't necessarily have to go and I can power that VM on and just pull the files out from a specific point in time too. So it's an option for file level recovery as well. So the big questions, and we guys like to be transparent about our pricing, is how much does it cost and how long is it going to take? And the prices are not set in stone right now, but for right now it's an MSRP. This is just a fixed cost. This isn't per node or per cluster. This is just the cost of the engagement service. We figure it's takes about 10 to 20 hours of actual work to get it set up and get the test facilitated. The bulk of that is probably going to be really setting up your remote access strategy and making sure that we can get your two sites talking to one another. The clusters do have to be able to communicate directly with one another as if they were on the same LAN segment. There can't be any netting involved. So really getting that is the bulk of it. And what's required? Well, you need to have 2 clusters or single nodes and enough bandwidth. Where you want to put that is entirely up to you and what you have as far as a goal or strategy for placing your DR site. It's not hard. We can get you guys connected with some regional providers that have pretty reasonable rates for both 1U and if you need full cabinets, or if you've already got another place on campus and you're thinking about maybe it's time to run some fiber over there and connect that way. But really, it doesn't matter where you put it as long as the two can easily reach each other, and you've got access to manage and maintain the cluster just for its basic, the basic care and feeding. If you have to get access to it to replace a drive, et cetera. But again, it doesn't. As long as they can reach each other, they can be across the globe as long as you've got the sufficient bandwidth. And back to the time it's going to take, realistically, even though it's probably 10 to 20 hours, we're end to end, this may be a 3 or 4 month project because part of it is going to be making sure that we can get a test facilitated with you. And that's obviously going to depend on your applications and your ability to take maintenance windows or what a DR engagement would look like. Every site, every application, every customer is different. So as we get into those, we discover everyone is going to be just a little bit unique, and that's why there's not a canned DR plan or runbook for every customer. It's a template that we can fill out. And that also becomes a living document that's a part of your ongoing infrastructure roadmap and strategy. So let's see, it's almost 38 after. I kind of drove through that in about 40 minutes. What kind of questions do we have?
Yeah, so what I'm going to do, I'm going to go ahead and unmute Blake and Dave. They both have been answering most of the questions, but Blake and Dave, you guys can choose anything that you think publicly should be talked about. So you guys should be unmuted.
All right, thank you. It looks like we have a lot of questions here. Okay. What was that original question we wanted to answer? Oh, when or is this or what? In what version is all this available, Mikey?
7.1.11. So that's the current LA version 7.1 is where it's available.
Another question that we had was, is there sort of an easy or low bandwidth way to seed this initial replication process?
If there is a lot of data, the easiest way is to take the 2 clusters and sync them next to one another. So if they're under the same roof and in the same rack, you're doing it at basically Ethernet line speed rather than across a WAN link. So the easiest way is to do it when they're next to one another. That's also another benefit of using a single node DR target is because then it's just one node, one U that you can ship pretty much anywhere.
Okay.
There's another question. This is from Biak Sang, where he was wanting some more details related to when not necessarily just doing DR, but backups as well. What options do we have for file level recovery? Yeah,
so getting a file back, the easiest option right now is to take a VM and power it on from its power it on from that clone and pull the file out that way. I'm not sure if we have. I know we're working on a method to basically boot from a snapshot and pull it out that way using a bootable ISO, so it's a little bit easier. But yeah, it's still at this point it's powering a VM on from a snapshot.
Yeah, we had one question that came in through chat, which was, is it possible to automate snapshot testing? I'm not sure if we have covered that or not.
I guess it would depend on how. I mean, it's easy enough to automate the creation of a clone from a snapshot, and power it on. That can be done, but then the validation that it's behaving the way you would expect it to once it's powered on would obviously be manual. But that could be automated if need be.
Yeah, I mean, it could be automated as long as you have the ability to get into the virtual machine once it's been brought up, and then do whatever validation that needs to be done, I would imagine.
Yeah, yeah.
Or test the availability of the application that's running there, or whatever it takes.
Yeah, somehow validate that it's behaving the way it's supposed to be.
Yep. Okay.
We also had a few different questions related to sort of just sizing and how long it would theoretically take to do the initial replication, or whether or not a specific link type would be supported. Can you give some recommendations around that idea?
Sure. So I've got a great baseline for this. Last year, some of our beta customers for DR as a service, one of them was I thought they had a 20 meg link. It turned out after the fact they had a 10 meg link, and they had about 2 terabytes of data to seed. And if you think about that, it's not just copying the initial blob of data. It's copying that, and maybe that took 4 weeks. But now you've got 4 weeks worth of chains that you have to get synchronized up. And so maybe that took 2 weeks to copy. So it takes a while to get fully synchronized. But in that case, it took about 6.5 weeks. And that was, basically 400 miles away from their site, our data center, on a 10 meg link. It took about 6.5 weeks to get fully synchronized. They didn't have a complex schedule. They were literally doing a snapshot every 5 minutes and keeping only 5 minutes worth, or only keeping 5. So there wasn't a whole lot of change that was going on in those 5-minute windows either. But realistically, if you've got a couple of terabytes to seed and it's over a 50 meg link, I would say that would take 2 to 3 weeks to seed easily. And so many variables, like, is that link dedicated? Do you have, is that just devoted for this, or is it being shared for VoIP or other user internet traffic, et cetera?
Okay, another question that had just come through was, I think you covered this, but is basically, can I specify only some servers? I think he means VMs to replicate to the DR node rather than all, to minimize the replication.
Yep, you can pick as many or as few as you'd like to replicate. I'll show that. Let me bring that up here. Yeah, so it's both the replications and the schedule are all done on a per VM basis. So I can have even groups of schedules or groups of VMs within different tag container with different schedules.
There's also a question about the uptime percentage that we could achieve with HC3. I'm not sure that we have any hard numbers on that. They were specifically asking about 5 nines. I'm pretty sure we can do at least 5 nines, if not 6 or more. Due to the fact that with all of the redundancies and high availability built in, there should be virtually no downtime. I don't know if you have anything to add there, Mikey.
Sorry, I was muted. The failover downtime, I mean, really, if you have things set up ahead of time, like, you've got multiple entries registered in DNS or something, or you've got all the networking part of it solved, it would be non-disruptive to users. We had a few from Hurricane Matthew when we've had DR engagements. That was a great litmus test for us from providing DR as a service to see how well it worked, and they didn't experience any disruption failing over or failing back. So yeah, I would say 5.9 is very doable.
Oh yeah. Another question is this service is asking about if this service is only provided in the U.S. I'm not sure if they are talking about this planning service specifically or like the disaster recovery as a service.
Yeah, so
speak
the
to that.
planning service is not available, is not limited to the U.S. Disaster recovery as a service is a U.S. only offering, but this planning service is available worldwide.
And then this is another question about the planning service. What if someone wants to refresh their DR plan after the initial plan is established? Would that be another go-around of the DR planning service, or how would we handle that?
No. So as part of the handoff, when we wrap up, you're going to get a copy of the DR plan. And it's, electronic, so you can obviously make changes to it as your environment changes. After the fact, if you've got some questions, I mean, that's why our support's so great. If you have questions about it, we can certainly look through it and say, yes, this looks good. But, once we set it up and provide you with the plan, and the expectation is that just the ongoing care and feeding of that hopefully shouldn't be too much more of okay, I've added a new server, I need to update my VM replica list and put it in the right order for restoration, et cetera.
Sorry, my little Q&A window is kind of small here, so scrolling through these.
All right, I'm reading. If the failover cluster is in a separate subnet and the primary clustering gets failover to the DR site, how do you handle the IP address changes on the guest? Great question. What we recommend doing is having multiple NICs inside of the guest with either a disconnected or disabled one of the NICs, but that has an IP address assigned to your DR site. And either having if it's Windows, a PowerShell script, or Bind, just a shell script to either update DNS as a part of your DR engagement process, or have them all registered ahead of time. Again, how that's approached will depend on your application. Is it SQL, it's expecting name pipes, or those can all be varied. But primarily, it's done with the DR network on the other side is different. Which in most instances, that's how it's going to work anyway. Because from a VPN tunnel, you couldn't have it on the other side. You couldn't have the same networks anyway. So it's all done primarily through DNS and multiple NICs.
Another question was, is it possible to send clones or VM backups to cloud backup services such as Amazon or Azure?
Not yet.
I mean, I think that part of the answer there is that you could do it by pushing those off to another. You couldn't do it with
native replication.
No, you couldn't do it with native replication, but you could do it with the third party, or by pushing them off of the cluster.
Yeah, so I mean, there's Azure Recovery Vault they have a pretty cool approach that I've tested. it does file level as well as giving you a system restore point. It's basically Windows backup that stores to Azure Cloud. That's not bad. It works fairly well in concert with us. Yeah, that would be the longer answer, I guess.
Yeah, it's just not built in as a part of our replication process. I had another question here. I mean, I've seen a couple questions about Veeam, whether or not a Veeam-like tool is available. And I mean, I think partly what we've shown here is that we have almost all of the capabilities of Veeam built in. So I'm not exactly sure what else they're looking for beyond what we're offering.
Yeah, I mean, I think that the functionality that everyone wants from Veeam is they want to say, okay, mount a snapshot and get the file from it. And in reality, we're doing the same thing of mounting a snapshot, and if you wanted to pull a file out of it, just it's an extra couple clicks of powering the VM on, but the process is still the same, except that we can keep a lot more snapshots and have a greater deck of recovery points. And in a way, I think that it's funny. Shane just said what I was going to say. Asking about mixing in maybe a file level approach for things like SQL or Exchange. It's always a great idea to have multiple approaches for DR, so you don't have them all tied into one vendor. It's fantastic that we're all built in, but that's a great compliment. And Shane, that's a great point.
Okay. Sorry, guys, we're just looking through the list of the questions here. There are so many. There's an interesting question. Is it possible to use L2 for DR?
Yes, yeah. Scott had asked that. Yep, that's fine.
The website indicates that Scale has a hosted facility that is for DR. Is that correct? Yes. Yes, it is.
Yes. Yeah, so we do have a DR as a service offering, which is priced on a per VM per month basis. So it's essentially a full service DR planning service, wherein we're providing a full management of your DR process, as well as providing the hardware and a remote site to host it. So if you wanted to go above and beyond just this approach of, we'll help you get it set up to, I need to have a vendor provided, I need a cloud solution to back up my VMs too. That's what we provide with our DR as a service. Our HQ wants to send out VMs to us using Veeam. Is there a workflow for this? I guess I'm a little unsure on how that process looks like, or what the question is. They send out VMs to you from Veeam. So I guess snapshots. From a Scale standpoint, we can import VMs, and we fully support importing HC3 VMs only. But if you have a VM and you can get access to the VMDK or VHD, and put that in a Windows share, we can import that. and it'll automatically get created into an HC3 VM. So if that's one way that they want to send VMs out, and we have a workflow doc to that, but just not using Veeam. Michael Gonzalez said, are the plans to change how snapshots are stored on the source? Yes, so there's a feature for, I call it incongruent snapshots, because today, every snapshot you have on the production cluster gets mirrored to the target. Even if it's one you manually took, they're all going to be mirrored in sync with one another. The ability to have incongruent schedules to say, maybe I want to keep more on my production or keep more on my DR, that's not available today. That's going to be coming in a release that I hopefully should be out this year. But the feature request that's underway.
We had another question, which was, are there any vendors of full backup solutions? So I guess that's talking to some of the additional backup features of like a Veeam or, maybe more application-specific backup features that we recommend that integrate well with HC3. So are there those that we recommend?
I mean, the most,
or just use whichever you like.
I'd say the most prominent ones for us are, we see a lot of Unitrends. That seems to be popular, but I mean, we see the same cross section of adoption that the market sees. So really any agent-based solution you're using today for backups, and installing that in your guest is going to work fine. No one can do native HC3 replication like we can, but outside of that, again, if you're at the guest level and you want to use that approach for file level protection, it's I've not run into one that has had any compatibility issues. Whether it's, again, I've been testing Azure Backup or Aperture, StorageCraft, Acronis, Symantec. I mean, they're all out there in use by our customers.
Could you go back to the slide for the pricing?
Yeah. I think we'll show that, Mikey, and then we have a ton of questions that we'll never get to before the top of the hour. So I think once we look at the pricing, we'll be aware of everybody's time. I know some of the presenters have things at the top of the hour that they got to do, so we will end at 3 o'clock, but we'll be sure to follow up with any of the questions that didn't get answered. So if you just want to walk through the pricing, Mikey.
Yeah, so right now it's a fixed cost, $4,000. That's MSRP, but that's going to include time for us to walk through the entire process for you, and then again at the end of it, we help you with facilitating a test and then getting a full DR plan completed. It's not per node. That's just going to be per disaster plan. But hopefully there's only one plan and no disasters.
All right, excellent. So as we did mention in one of the questions, we will be sending out a link to this webinar and a follow-up email. We will have all the questions that were unanswered, and we will be sure to follow up on those. If anyone does have questions, please feel free. You can reach out to info@scalecomputing.com, and that will come in, and I can be sure to filter those to the correct areas. I want to thank everybody for joining. Great content, Mikey. Thank you, Dave and Blake, for the Q&A. And everybody gets about 30 seconds of their day that we had planned to spend with you. So, again, thank you, and look forward to future events.